Example number 4 says a rock was thrown straight up with a speed of 11.5 from a height of 15 and on its way down past the point of release hit the ground below. Ignoring air friction, what was the speed when the rock hit the ground and what was the total time of flight? Interesting question. So what we'll do with this is we have a little diagram to help us. It goes straight up and then it comes down, and of course the initial velocity was 11.5. The displacement is negative 15 meters. The acceleration is 9.81 negative. And those are the three variables, all right, initial velocity, displacement, and acceleration that will help us to find the final velocity. So of course, since we know initial, final is unknown, distance and acceleration are given, we can say that Vf squared is equal to Vi squared plus 2AD. And of course that's equal to 11.5 meters per second squared plus 2 times negative 9.81 times negative 15. Notice the two negatives will cancel and we get 11.5 squared, which is 132.25, plus 2 times 9.81 times 15 gives me 294.3. So we take the sum of those two, 294.3, and we end up with 426.55. 426.55 meters squared per second squared. That's Vf squared. And so Vf is equal to the square root, which is 20.653 meters per second, or 20.7 meters per second. Now, they ask for the speed, so do we need to give direction? Of course we don't. But of course we know that it's going to be going down. Now that we know that the final velocity is 20.7, we can help to solve for the time of flight. So this would be negative 20.65. I'll go back to the original value. And initial velocity was 11.5 positive. The acceleration of gravity is negative 9.81. We also know that the displacement was negative 15.0 meters. They want us to solve for time. Time in this case is our unknown. Now, there are a number of different equations you could use, but some of them are more difficult to use than others. I would recommend that you try the simplest one, which is A is equal to Vf minus Vi over T. T then is equal to Vf minus Vi over A. And of course that's equal to negative 20.65 minus 11.5 divided by negative 9.81. And we end up with T is equal to 20.65 minus 11.5 gives me a change of velocity of 32. From its initial velocity of 11.5 to its final velocity of negative 20.65 is a change of 32. We divide that by the acceleration, negative 9.81, and we get 3.277, okay, 3.27 seconds, or in other words, 3.28 seconds. So the total time of flight is 3.28 seconds. All right, excellent question.